Hi, welcome to our channel Good New. Let's get to the point of the day. When we talk about global semiconductor chips, we immediately think of companies like Intel, TSMC, Qualcomm, MediaTek, and Huawei. These are, of course, common chip companies on the market. And then I had a thought: who does the technical reserve and output for these chip companies? The solution is a lithography machine. So, who is the current manufacturer of lithography machines? ASML. Surprisingly, I discovered through a search engine that ASML has always had a monopoly on lithography machines in the world. So, how did ASML achieve its current position and monopoly? Today, I am pleased to introduce a new topic on why the EUV giant ASML can become the world's leading lithography machine manufacturer. What exactly is a lithography machine? Let us first define what a lithography machine is. According to my knowledge, the lithography machine is the main piece of equipment used in the production of large-scale integrated circuits. Manufacturing and maintenance necessitate a high level of optical and electronic industrial foundations, which are only mastered by a few manufacturers worldwide. As a result, lithography machines are expensive, typically costing between $30 million and $500 million US. It is not an exaggeration to say that it is not a money printing machine, but it is more valuable than one. There are numerous lithography machine brands, which can be classified into the following categories based on different technical paths. There are two types of high-end projection lithography machines: stepping projection and scanning projection lithography machines. The resolution is typically between 7 and several microns. The most precise instruments in the world are high-end lithography machines. A lithography machine worth $100 million. The flower of the modern optical industry is high-end lithography machines. They are so difficult to produce that only a few companies in the world can do so. The global brands are primarily ASML from the Netherlands, Nikon from Japan, and Canon from Japan. ASML is the clear winner among them. What is the working principle of the lithography machine? Let me first explain the operation of the lithography machine to you. The implementation of almost every process in the chip manufacturing process is inextricably linked to photolithography technology. Lithography is also the most important technology for chip manufacturing, accounting for more than 35% of chip manufacturing costs. When the chip has completed the IC design, the wafer foundry must be entrusted with chip manufacturing and packaging. Wafers are the building blocks for all types of computer chips. We can compare chip manufacturing to building a house with building blocks, and we can complete our desired shape by stacking layer by layer. However, without a solid foundation, the house will be crooked and unsatisfactory. A stable base plate is required to build a perfect house. The wafer is the substrate used in chip manufacturing. Photolithography is used to create the circuits and functional areas needed for chip fabrication. Consider the processing of film photos. The mask represents the film, and the lithography machine represents the processing station. Etching technology is used to copy the chip circuits on the mask to the photoresist film one by one. On the wafer, the circuit is painted. The imaging ratios of various lithography machines vary. It is then chemically developed, resulting in a circuit diagram etched on the wafer. Lithography determines the precision of semiconductor circuits, as well as power consumption and chip performance. The most advanced technologies in the fields of integrated materials and optics are required for related equipment. Lithography machines are classified into three types based on their ease of use: manual, semi-automatic, and fully automatic. So far, ASML has established a monopoly. Only the Netherlands-based ASML is the pinnacle of the global high-end manufacturing industry, producing 20 high-end pieces in a single year. Every year, TSMC and Samsung are said to have broken the head for this. So, how about ASML's evolutionary history? ASML began as a small joint venture company owned by Philips in the 1980s. The company has 31 employees, including the CEO, who are still huddled in a temporary prefabricated room next to Philips headquarters, and sales are only possible in the name of the parent company, which is extremely difficult. There were dozens of companies that could make lithography machines in the era when the wafer manufacturing process was still in the tens of nanometers, but Nikon became a well-deserved giant with the accumulation of the camera era and the overall rise of the Japanese semiconductor industry at the time. In just 4 years, the United States, the former powerhouse of engraving machines, was dismantled, on an equal footing with the old King GCA, and won 30% of the market share. At the time, the eagerness of several major customers, including Intel, IBM, AMD, and Texas Instruments, who waited at the Nikon gate every day for the latest products to go offline, was comparable to the eagerness of everyone now awaiting the delivery of ASML's EUV lithography machine. Gordon Moore, one of Intel's founders, proposed Moore's law, which states that the number of transistors that can be accommodated on an integrated circuit will double every 18 to 24 months. Once more, the corresponding wafer process will continue to shrink. And with each process advancement, chip performance will improve. This is a requirement for wafer design, but it also means that the lithography machine must be one step ahead of the design process and deliver equipment that meets the specifications. In the era of tens of nanometers, the threshold for lithography machines is actually quite low. ASML, which has over 30 employees, can easily enter the industry. Even Intel, which designs chips, can make a few and test them. Piece together the high-priced parts that were bought back, and pile up a device that is slightly more difficult than a camera. The difference between Nikon and them is that their competitors rely on the industry chain to collaborate, whereas Nikon's component technology is all done in-house, much like Apple, where chips and operating systems are all in one package, with only a few chips removed to deal with chips. The procedure is sufficient. However, whether making chips or a lithography machine, the level of the level actually increases exponentially. The wavelength of the lithography machine's light source was stuck at 193 nanometers in the 1990s, which became a roadblock for the entire industry. Overall, current technology companies such as Intel, Samsung, and TSMC introduced extreme ultraviolet lithography technology at the 7 nanometers node, and an EUV lithography machine is a lithography machine that uses extreme ultraviolet as a light source. Of course, this is not as simple as switching out a light bulb. However, technology has advanced to the point where it is difficult to do so, regardless of method. So, when we use an ASML chip and a lithography machine, we must respect both the chip and the hard work of the technical staff. Thanks for having your watching in this video. You can add your ideas or suggestions below. Please keep following our channel and like our videos.